You know, I always get nervous when I have such very effulgent, just incredible laudatory introductions like this, and this is associated with a Lifetime Achievement Award, which makes it sound like I'm not going to do anything else after that. I hope I get to do some more things, too. First of all, I wanted to tell you that I had this space shuttle discussion was especially poignant for me because when I was a lot younger, I grew up in the Los Angeles area, and I worked at a company called Rocketdyne, which made the F-1 engines for the Apollo program. And my job was to do the statistical analysis to see whether the engines would actually last long enough to burn up all their fuel so that we could get the spacecraft up into orbit. I don't know if you've ever been a couple hundred yards away from 1.5 million pounds of thrust going off in a fixed jig, but it was pretty exciting. I was 18 years old at the time. And I thought, that was like around 1961 or so, and I kept thinking that, God, 20 years from now, we're going to have regular launches of rockets, coming out of either the Santa Susana Mountains or maybe out in the desert somewhere. Of course, 1980 came along, and we didn't quite have them every week, but we certainly clawed our way into space. So for me, this is a very special occasion. The other thing which is very special about being in this room, surrounded by these models of the spacecraft, is that the story of the Internet is very much dependent on some of the things that Intelsat did. And we all know the story. ARPANET was a packet switch network. It used fixed line, telephone line, dedicated circuits to connect the pieces together. But what really drove Internet was the idea that we could take satellites and make them into packet communication systems and take mobile radio and do the same thing. So when Bob Kahn began exploring those ideas at DARPA and joined me at Stanford, he asked the question, how do we hook all those different kinds of packet switch nets together and make them look like one? And I want to acknowledge Estel Hoverston. If you raise your hand over there in the corner, Estel, please. Estel was part of the packet satellite team that actually made satellites into something other than point-to-point or broadcast systems. And that was really crucial to convincing all of us that we needed to do something different from what we had done on the ARPANET. So the story here is that, the ARPANET begets the Internet. Then the Internet becomes an infrastructure. And then people can build on top of that infrastructure. And the next infrastructure that came along was the World Wide Web. Sir Tim Berners-Lee recognized that if he could put this layer of additional protocol on top of the already existing infrastructure, more things could happen. And what's important is that these are open infrastructures, and lots of people can try their ideas out without having to get permission first. This is permissionless innovation, and I cannot tell you how important that notion is. It's very critical to preserve the ability to let people try new ideas out. The next thing after that comes the mobiles that are carrying more computer power than anything you saw earlier today, especially with Arthur Clarke in that room full of very large-scale computers that can't do anything near as much as what you carry in your pocket today. So that infrastructure links the mobiles to the Internet resources. You carry your information window in your pocket. When you tweet, the tweets don't come out of your mobile and go to all the other mobiles. They go to the Internet. Then they get radiated out of the Internet, and they come back into the mobile system after that. So you get layer upon layer of open architectures and application programming interfaces that let other people try things out. And that is the essence of creativity. So now, where do people like Arthur Clarke come into this? Arthur Clarke and Isaac Asimov, Hal Clement, Heinlein, Robert Forward, these are science fiction authors who give us the freedom to imagine.